Bing, bing, bong, bong, bing, bing, bing. You know what that is, right?
Hello, beautiful people of Virginia. As you all know, the election is in 2 weeks, and we're gonna win. Don't worry, we're not gonna let Hillary take this election. I have the best statisticians on the job, and they say that we're gonna take Virginia. No doubt about it.
Imagine you're a statistician working for Donald Trump before the election. Your job is to determine whether or not Donald Trump is going to win the electoral votes for the state of Virginia. How can you accomplish this? By using a procedure called a significance test. In this video, we will look at the different outcomes of a significance test. A significance test is a test used to compare observed data to some expected result or claim that we want to assess. In this case, we want to determine whether or not the population proportion P of people in Virginia who plan to vote for Donald Trump is at least 50%. This claim is called the null hypothesis. The null hypothesis is a claim tested by a statistical test. Thus, we will try to find evidence to show that Donald Trump will not win Virginia. This claim is called the alternative hypothesis. If we can prove this, then we know Donald Trump will lose. If we fail to find evidence to suggest that Donald Trump will lose, then we will fail to reject the null hypothesis. In order to perform the significance test, we need to collect a sample. This sample will yield a statistic that is an estimate for the unknown parameter we are trying to find. In this case, we take a sample of n individuals from Virginia and ask them whether or not they plan to vote for Donald Trump. The percent of individuals from this sample that support Donald Trump is our statistic, also known as p-hat. We will then calculate the p-value, or probability, that our sample would take a value as extreme or more extreme than the one we observed. If this p-value is sufficiently small, then we know that the difference between our statistic and the expected parameter is not due to chance, and we can reject the null hypothesis. We will call this difference statistically significant when the p-value is smaller than some value alpha. In this experiment, we will use an alpha value of 0.05. With our prediction set, there are now 4 possible outcomes. In the first case, we get a type 1 error. This means that we reject the null hypothesis even though it is actually true. This means we think Donald Trump will lose, but he actually wins.
Alright, give it to me straight. What are my chances of winning Virginia?
Well, Mr. Trump, based on the significance test, the p-value of the null hypothesis is...
Whoa, hold on, slow down there. Just give me the number.
Well, Mr. Trump, you're probably going to lose with 42%.
You're fired.
This just in, Trump wins Virginia with 52% of the vote.
Huh. Oops.
In this case, we made the wrong prediction, but what actions could we have taken to prevent this from happening? The probability of getting a type 1 error is equal to the alpha value we defined earlier. A small alpha value will mean a low probability of rejecting the null hypothesis, and thus a low probability of getting a type 1 error. However, there are consequences to decreasing the alpha value, as we'll show later. In the second case, we reject the null hypothesis when the alternative hypothesis is true. This means that we correctly predict that Trump will lose the election in Virginia.
Alright, give it to me straight. What are my chances of winning Virginia?
Well, Mr. Trump, based on the significance test, the p-value of the null hypothesis is...
Whoa, hold on, slow down there. Just give me the number.
Well, Mr. Trump, you're probably going to lose with 42%.
You're fired.
The results are in. Trump loses to Hillary with only 42% of the vote.
In the third case, we fail to reject the null hypothesis when the null hypothesis is true. This means that we correctly predict Trump will win the election in Virginia.
Alright, give it to me straight. What are my odds of winning Virginia?
Well, Mr. Trump, we did a significance test to determine the p-value of the null hypothesis.
Whoa, hold up there. Just give me the number.
Mr. Trump, you're going to win Virginia with 52% of the vote.
This just in, Trump wins Virginia with 52% of the vote.
Huh. So, you want to be Secretary of State?
Yeah.
Cool.
In the fourth and final case, we get a type 2 error. This means that we fail to reject the null hypothesis, even though it was actually false, meaning the alternative hypothesis is true. This means we think Donald Trump will win, but he actually loses.
Alright, give it to me straight. What are my odds of winning Virginia?
Well, Mr. Trump, we did a significance test to determine the p-value of the null hypothesis.
Well, hold up there. Just give me the number.
Mr. Trump, you're going to win Virginia with 52% of the vote.
This just in. Trump loses to Hillary with only 42% of the vote.
In this case, we made the wrong prediction. What actions could we have taken to prevent this from happening? The probability of getting a type 2 error is known as beta. Beta is dependent on many factors, including sample size and the value of alpha. If the value of alpha is very small, then the value of beta will be very large. Thus, by decreasing the chance of a type 1 error, we increase the chance of a type 2 error. As you can see, there's no way to eliminate the chance of type 1 or type 2 errors, as decreasing the chance of one will increase the chance of the other. So it's important to evaluate which error is worse so you can reduce the chance of getting that outcome. In our scenario, it's worse to make a type 2 error, as predicting Donald Trump will win Virginia when he's actually projected to lose will make Donald Trump campaign in different states, ensuring his defeat in Virginia.
Go.
Alright, give it to me straight. What are my odds of winning
I
Virginia?
forgot my lines.